Namaste. Welcome to the DVR Black Tech. Now we are going to implement the 2:4 decoder in Xilinx Spartan 6 FPGA. So for that, the first of all, decoder means any input that is, for example, 2:4. So two inputs are given that is split up into the four outputs. That's called as the decoder. That means any signal that we are giving that will be split up into the four digital signals. Basically, it's a digital, okay, 2:4 decoder. Now we will come to see the block diagram of this 2:4 decoder. Okay, this is the block diagram of 2:4 decoder. Now we are going to implement that in the data flow modeling. So for that, we are not going to think about the gate structure, but it is just like the block diagram of this 2:4 decoder. So this is the block diagram of the 2:4 decoder that has the input A and the B and the output Y0, Y1, Y2, Y3. So we will make this even bit easier, okay, by using the concept of the vector. Vector means it is like I think you have now a of 0, a of 1, a of 2, like that, which has the same variable name, and the inside the bracket we are going to represent 0, 1, 2, 3. That is the just a format of the vector. So that's the array. Basically in programs we call it as array. In Verilog we call that as the vector. Vector may be the register or the wires. Okay, so the vector, it is represented like a of 0 and a of 1, like that. We are going to use that. So for a 2:4 decoder we have the two inputs, that is a of 0. In this diagram we have a and the b. Instead of that we will just consider a of 0 and a of 1, and the output y of 0, y of 1, y of 2 and the y of 3. So in 2:4 decoder we have the a of 0 and a of 1 as the inputs. Then the output are y of 0, y of 1, y of 2, y of 3. So here we can see I'm just going to change this to this is my a of 0 and this is my a of 1. Okay, this is my a of 1. But instead of this we just take this as reverse. This is a of 0 because that has to be the LSB. The LSB has to be the a of 0, and this we just take this as a of 1. Okay, don't confuse, the MSB is a of 1 and the LSB is a of 0. So this is the LSB. Okay, from your side, this side is the LSB and this side is the MSB. So 0, 0, and we are going to have the output for Y0. Here we can see the output for the Y0 for 0, 0, and then whenever it is 0, 1, the output is for Y1, and 1, 0, the output is for Y2, and the 1, 1, the output is for Y3. So the two signals, that is the A0 and the A1, that gets split up into the Y0, Y1, Y2, Y3. So 2:4 decoder. This is the one type of decoding. You can use anything, because for the instead of 1 here for Y0 you can use for Y2, and in the Y2 for this one, okay, for 1, 0 you can have here. That means at a time you just have to maintain the decoding properly. That means only for one output this has to be high, and for the remaining this has to be 0. So it may be 0, 0, 0, 1 and 0, 0, 1, 0 and 0, 1, 0, 0 and 1, 0, 0, 0, like that also possible. Anyway, that's your wish. Okay. Now we are going to just implement this in Xilinx Spartan 6. That means this FPGA in this FPGA. So for that we have to use the ISC tool. Okay, ISC tool to write the Verilog code. So just go to start and just type ISC design suite, and here I have to write the ISE. It will going to open the project manager, that means the project navigator, and here just go to the just click on this and just go to the file in the new project. So the name of our project is decoder okay, decoder, and that is 2:4. Okay, 2:4 decoder. And here we have to fill some specify values. For if you are the first time users, then you have to fill some values here. That means the family and the device, which device you are using, all those things, so that you can get from the this FPGA manual or its specification, or you have to see. Okay, I think it's visible now. You have to see here. Okay, the Xilinx Spartan 6, and here XC6SL, that same thing is here you can see. Where is that? Yeah, here you can see XC6SL X9. Okay, this is the device. Okay, this has to be matched. Okay, okay, this is the Spartan 6. Yeah, this is correct now. Then click on the next and click on finish. Then now we have to create the new source file, that is the Verilog module. So just go to the Verilog module and decoder. Okay, decoder, and that is 2:4. Okay, now these things I'm just going to write in the program itself, the input and the output port, or yeah, now we are going to use the vector concept. That means for y of 0, y of 1, y of 2, y of 3, and a of 0 and a of 1. So for the time being, I just here I have the code. I just copy paste it for the time being. Okay, this is the what we just we have to implement. Okay, so here we have the decoder 2 to 4, the same name, decoder 2 to 4. This is the module name, and here the that means we are instancing, not instancing, we are just naming our module name, and the last one is the AND module. Okay, then here we are declaring our port declaration. What are the ports we have? The output and the input. Okay, input ports we have A0 and A1, that we can see here. In this diagram, we have the input as A0 and A1. Okay, this is A0. Okay, this is A0 and A1. Okay, and here these are the output ports. Okay, so the ports means it is like the connection with the external environment. That means we have to give those signals, right? So we are calling that as a ports. So here y and a, since we are using the vectors, we have to just write y comma a. Okay, otherwise we have to write like y0, y1, y2, y3, a0, a1. That's so large. So instead of that, we are using the vectors now. So y0, y1, y2, y3. There are 4 variables we require. That means the 4 output we require. So this is output. Then after the declaration of the ports, we have to specify which are the outputs and the inputs. So output 3 to 0. Because it is like 0 to 3 or 3 to 0. We have the 4 outputs from 0, 1, 2, 3. So it is 3 to 0, and is the output y, and input that is A0 and the A1. So input 1 to 0, that is 1. Then we already, I think, equation. Okay, now we have to think about the equation. What is the equation of this y0? So from this truth table, the y0 can be, we can just okay, y0 is equals to a, that means a0 and a1 both are 0. So a0 bar dot a1 bar, that means and a1 bar. Okay, then for y1 it is a0 bar. Okay, don't confuse. Okay, sorry, this is the a0. Okay, this is the A0 and this is the A1. So for Y1, it is A1 bar and A0. And for Y2, it is A1 and A0 bar. And for Y3, it is A1 A0. I think you understand how to write this. This is just a multiplication of with respect to 0 and 1. That's it. Wherever the 0 is there, you have to write a complement, and wherever the 1 is there, that is either A0 or A1. Okay. So here we have y of 0, that is equals to y0 bar, and this one, another one, that is that means A0. Sorry, it's not a y0 bar, it's A0 bar, and another one, that is A0. Okay, so here I think this has to be okay, we will just see A0 and A1, right? So what is that? A0 and A1 both has to be A naught bar and A1, not of A1. Okay, now it is correct. Then 0 1. Okay, yeah, I think, yeah, first has to be 0 0. Both are 0. Okay, now we will fill this table. That means we will just going to write the Boolean equation according to this, what we can see from this. Okay, so now here we have for the y naught, that is a naught bar and a1 bar. So this is not of a naught, that means a naught bar, and here not of a1. Okay, not of a1. This is not correct. This simply I just wrote. So this one is now okay. This is now proper. Then y of 1. Okay, y of 1 is a naught, and yeah, I think here we can see this is a naught, and here we have a1 bar. So here we have the a naught. This is not. Okay, this is a naught, and naught of, okay, naught, where is that? Yeah, this is the naught of a1. Okay, now this is correct. Then comes the okay, then comes a1 and a naught bar. Okay, so a1, okay, here we have a1 and a naught bar. That means naught of, okay, naught is this one, naught of a naught. That means yeah, a1 and a naught bar. This is a naught bar and a1. Then yeah, this is correct. Now the y3 is a naught and a1. So for that we have to make okay, this is 0, a naught and a1. I think now you have understand. This is a naught bar, a1 bar, and then is a naught, a1 bar, and then is a naught bar, a1, then a naught, a1. I think you understand this now. Okay, now we are assigned this. That means by this is the assign keyword. It is basically used in the data flow modeling when we assign. Okay, we are not thinking about the gate structure now. It is just a data flow modeling. Then after this we just have to write the AND module. Now it completes the our program. Okay, 2:4 decoder. Now let's compile this, and we'll just going to implement this to the board. So generate program file, and do you want to save the changes? Okay, yes, add change. Now it is synthesizing. Okay, here we have y0, y1, y2, y3. Now it is synthesizing. Yeah, it is correct. The syntax and all these things are correct. And now we have to implement this for the board, and we have to check. So before that, one thing I forgot. So for the board, when we are implementing to the real board, we have to specify the input and the output. That means here we specified the output and the input. But for the board, there are here we can see there are lots of pins. These are all the some GPIO pins, and here some buttons and LEDs. We have to specify the address, which is the output and which is the input. That one we have to write in the user constant file. That means the UCF file. So we just have to go here, and yeah, not here. We just have to go here. Okay, it is selecting the both. Yeah, now new source, and here we have the implementation constant file. Okay, implementation constant file. So here you can see the UCF is there here. Then I'm going to call this as a pinout, then click finish. Okay, now here we have to specify the pinout for this. So we have the two inputs. So for that, now we will just use these two DIP switches as the input, and the LEDs, that is LD2, LD3, LD4, LD5, the middle ones, those that we can use as the output. Okay, that can be anything, but for simplicity purpose, those we can use for the input and the output. I think it's visible here. 4 switches are there, and these LEDs. So this pinout is depends upon the FPGA board. That means it's a board specific. So along with the board, they prepare the that means board manual. So just refer that, and you will going to get these things. So for this board here we have that. Yeah, for DIP switches, I'm going to just use the two switches. So Control C and okay, two switches, and output I'm going to use the four LEDs, that is two, the middle one, 2 3 4 5. Okay, 2 3 4 5 we just going to use. So yeah, now here the DIP switch 1, that is my input. Here we have to see what is our input. Okay, not here. I just have to click on this V file, and my input is A of 0 and A of 1, and output is Y of 0, Y of 1, Y of 2, Y of 3. Okay, so okay, not this one. Where is that? My user constant file, that is pinout.ucf. Okay, so here this is my output. So Y of okay, what is that? Okay, TL. Okay, so here instead of this I have to write Y, then here also Y, and here also Y. Okay, then I have Y of 0 and Y of 1 and Y of 2 and Y of 3. Okay, what are the same names that since we use this as a vectors, you have to write like this: Y of the smaller and the greater symbol in that 0 1 2 3. We have the 0 to 3 as the output, and input is DIP switch. So that is A of okay, A of 0, and here A of 1. Okay, yeah, then A of 1. Okay, so two switches we have. Then Control S. Okay, now I have to generate a program file. Now if we have any errors, it will going to show now. Okay, it is compiling properly. There's no any syntax errors. So okay, we will connect the board. I'm just going to connect this. Yeah, I just connected, and these switches. Okay, these are the four switches here. Yeah, after this we have to implement this to the board. So for that, yeah, now all are in green marks. So successfully it is generated. Now I have to just go to manage configure project, and or not this okay, that one, that similar thing. Okay, manage configuration project, both are same. Manage configuration project, then here just go to the boundary scan, click on this and initialize chain, and yeah, now it's detected, and it is asking if you want to want to add the configuration files. Yeah, I have to add, and okay, where is that? I think it is not at the IC where I saved. I think, yeah, it is here. The decoder, where is my decoder 2 to 4? Okay, decoder 2 to 4 dot bit. This is the bit file that is generated, that I just added. Then the file that just click is no, because we don't want that PROM. Then click apply and click OK. Okay, now here we have that board. Sometimes it will not going to implement properly at the first time. So yeah, I think it's visible properly. So now, okay, I'm making all these DIP switches to 0 0 0 0. Okay, then program it. Yeah, now it is programmed. Now we will check whether it's successfully programmed or not. So whenever it is 0 0, but it's not giving anything, right? Yeah, it's not giving anything. We just I will just disconnect, and I will just re-upload the program. Okay, okay, program it. I think the program is proper. We'll just check once. Yeah, the same thing I uploaded, you can see, but I tried 2 to 3 times the same program. That's due to some technical mistakes. Sometimes it happens, you will not get the exact output, but just try 2 to 3 times, you will definitely get for the same program. So here you can see that this is what we have. And okay, then pinout.ucf, the same thing. Okay, the A0 and A1, the same thing we have. And we just have to go to here, the same thing. Okay, manage configuration project and boundary scan, then click on initialize chain. Yeah, here we have that, and click yes. And we have to choose the bit file. We have to go to that project where we created that same. So here decoder 2:4, then click open this bit file, click on OK, then click no. Then we just have to the okay, I'm just going to disconnect and we'll check it again. Okay, yeah, now I just reconnected and these are all 0. And now I have to program this program. Yeah, now it's working fine. For 0 0 it is giving the output as y1, and whenever, that means y not, and whenever I make 0 1, I think it's visible. Okay, I think yeah, now all are at 0 0 0 0, all are this side, so it is 1. And if I make any 1 to the, okay, I'm just make this as 1, then you can see the changes. So now this is 1 0. So 1 0, no, I think yeah, it is 0 0. And now this is 0 1. Okay, 0 1. This one is my LSB and this is the MSB. So 0 1 and 1 0 1 0. So for that 1 0, this one, and 1 1, the next one. Okay, this is what we just implemented in this FPGA. I think you've understand how to do this. Thank you.